In this video we will see concept of friction. Here we have two type of friction, which is static friction and dynamic friction. Static friction acts when body is at rest and dynamic friction acts when the body is moving. So here this concept is called as a Coulomb's concept, where Coulomb's friction, where these two surface of the the surface and the block, between these two there are two surfaces, one is of block and one is the surface of the floor. So these two surfaces are dry and they are not lubricated. So this way of analyzing and the frictions which are involved are called as Coulomb friction. So now if we see there is a block and we are pulling it with a force P and the weight is acting downward, which is W. So this block will have some friction in the backward direction, which is shown by this force F. So this is a friction force which is acting on this bottom surface. Due to the weight there will be normal reaction. If we draw a free body diagram of this block, this weight will be acting on the floor and similarly the block will be experiencing some normal force. So that is why this body is not moving in vertical direction, because both these forces are balancing. Now we are applying the force P and friction is generated. This friction and the normal force, the resultant of which we say this reaction force R will be equal to under root of f square plus n square, and the angle with the normal of the resultant force will be called as a friction angle. And the coefficient of the friction, which depends on the surface, mating surfaces, means both the surfaces, will be mu equal to F upon N. So the frictional force will be mu times N. Now here if we draw just reaction force, reaction due to this two, normal and friction force, resultant force, then we can apply Lamis theorem and Lamis equation here, that P, W and F are passing at this point when they are concurrent, and phi is the angle with vertical with the R. So now we have to take opposite angle to the force. So R upon opposite to that R will be 90 degree, so sin 90, W upon sin 90 plus phi, and P upon sin 180 minus phi. So this will be the angle. So this is the Lamis theorem we can directly apply, which is a useful concept for solving numericals. Here if you see the graph, when we start pulling the block, initially the force will be 0, so there will be no friction developed. So this graph is of friction on the vertical axis that is developed, and P is the force we are applying. So when we start applying from 0, friction start developing. As we increase the P force, initially due to the friction force the block will not move, so the static friction between the block and the surface will increase, and at the limiting friction there will be maximum friction, and after that only the block will start move. So when the block starts move, there will be dynamic friction coefficient will be acting. This is a static friction coefficient. Dynamic friction coefficient, which will be lower than the static friction coefficient, and dynamic friction will be less than the static friction. And so after, once the body starts moving, there will be drop in the frictional force. So in some questions, if the P is less than the limiting friction, let's say P is applied half of the limiting friction, then friction force also will be half. So that will be the trick question, where they have asked how much will be the friction developed inside the body if we apply certain force, and if the force applied is then less than limiting friction, then we do not have to write about the limiting friction. We cannot apply we cannot find it by just limiting friction. Instead we can directly say the friction developed will be equal to the force applied. So that is how we have to answer it, otherwise there will be negative marking in the gate examination. Now we'll see some examples. Here there are two blocks, having mass small m and capital M. The larger one is having capital M. So here we are applying force P to the smaller block. If we draw the free body diagram, then the force P will be acting. The friction between these two surfaces will be acting, which is F1. The weight of the mass M will be acting downward, and due to this bigger mass, there will be normal reaction applied. Because of the weight applied on this block, the same reaction will be applied on the smaller block. So now if we apply the summation of fx and fy equal to 0, then n1 will be equal to mg directly and p will be equal to f1. Now applying this concept of coefficient of friction, we can find f1 will be mu times mg, because n is equal to mg, so f1 equal to mu mg equal to mu mg. So this is how we can find p and relate it to mg. Now if we apply free body diagram to the bigger block, then if friction 1 is acting on this side on this block, then opposite will be acting not in this direction. In this direction it will be acting f1 on the capital M, and the floor here we are having this, both the mass will move forward, and this bigger mass will move forward because of f1, because the only friction force due to the first block is applying on the second block. So now this normal force is acting upward, on this block it will be acting downward. Mg or capital Mg will be acting downward, and due to both these force there will be normal force due to this surface, which is N2. The friction force on this surface will be acting backward only, and which will be f2. So now we can directly write summation of fx equal to 0. So this can directly say that f1 and f2 will be equal, and if we apply the vertical force balance, then n1 plus mg equal to n2, n1 plus mg equal to m2. Now we can directly write that n1 is equal to mg, this capital Mg equal to n2, and n2 we can write as, if we take a g common, then g m plus m. Now we know that f2 will be mu2 times n2. Here the coefficient of friction will be different than these two surfaces, because it depends on the surface to surface contact. If there are different surfaces, then there will be mu value different. So here f2 will be mu2 n2. Now n2 we have found that this is the n2, we can directly write this, which will be equal to f1. This is how we can solve such problems. And the last kind of problem, which is the inclined surface. So suppose there is a mass m which is resting on the inclined surface. This is the angle of repose, we call it as angle of repose, and this phi is called as friction angle. So here if the block is there, and if the angle of repose is enough so that block will start sliding, then it will slide with acceleration a. Here horizontal with respect to this inclined surface will be x, and normal to this inclined surface will be y. So here if we analyze that mg will be acting, due to the weight mg will be acting downward. Now if we take component with respect to angle of repose, so same angle if you calculate by trigonometric, this will be the angle theta as same as the angle of repose. So here the component will be mg cos theta and mg sin theta. So this force we can divide into these two components. Now friction will be acting opposite to the motion. So if motion acceleration in downward direction, friction will be f, which is upward. So always we have to take friction opposite to the motion, and the normal force will be acting normal to the surface. So this is how the force will be balanced, and now we can write that n will be directly equal to mg cos theta, and friction we note that it will be equal to mu into n, and mu into n, and n is mg cos theta. So f will be equal to mu mg cos theta. Now if we apply the summation of fx in this direction, then we can say that friction and these two forces will be equal, and the acceleration is downward. So we can write summation of fx equal to m into a. Here mass into acceleration in x direction we have to write. So here we can write the mg sin theta, because acceleration in this direction is there, so we have to take this direction positive. So mg sin theta minus friction will be equal to m into a. This is due to Newton's law of motion. So here we can write mg sin theta minus friction from here mu mg cos theta, which will be equal to mg. So we can cancel out mass from this equation and take out g common. We can write acceleration will be equal to this. So this is how we can find the acceleration. There are many different kinds of friction problem, but the basic concept is we have to draw free body diagram and apply the equation of coefficient of friction, which will be friction force upon normal force. And sometimes we have to apply the Lami's theorem to solve it faster. And this is how we can solve any problem, by just drawing the free body diagram of each and every block. This problems is a little bit tricky when if we draw incorrect free body diagram, and then there will be problems in such numericals. But it is very easy if we draw a correct free body diagram, there are some steps which are particular for friction problem, and it is very easy if we go step by step. So thank you for watching this video, and see you in the next video, and please share and subscribe the channel, and see you in the next video. Thank you guys for watching.